Okay, here's how we could use algebra to solve the Shake Shack problem from page 1. Now, we don't have page 1, but we do need to read this paragraph because there's some information in it that's going to help us with this question below. Remember that a shake at the shack cost 80 cents, and the bill for 3 burgers and a shake was $4.40. The question was, how much is a burger? Well, we don't really care about that question. We just needed to read that top paragraph because we're going to need some information from it for this question that we're about to work together. So let's go down here. At the Shake Shack, 2 orders of fries and 4 shakes cost $5.90. How much is an order of fries? Okay, well, when you look up there at the information given above, do they tell you anything about fries? No. We know we want to order some, and we actually want to order 2 orders of fries. Is that all we're ordering? No. So we need to add to our order. What else are we ordering? Do we know anything about shakes? Right. This $5.90 is the total for your entire bill with the 2 orders of fries and the 4 shakes. So if you are ordering 4 shakes and you know they're 80 cents each, how much of the bill is it going to be? So now that you know your shakes cost that much, but your total bill is that much, how can you use that information to find out the cost of each fry? Jenny Beth? Right. You subtract the cost of all your milkshakes from your total bill, and that lets you know that how much of the bill was just fries. $2.70, but that's for 2 fries. To figure out each fry by itself, divide by 2, so each fry was how much money? Correct. Alright. Judd figures the prom will cost him $160. He has saved $46 and can earn $6 an hour at his job. How many hours will he have to work? Isn't he starting with $46 that he's already made? But he's continuing to make money, so we added that money at a rate of what? $6 an hour. And yes, you can use X, but for this one, I'm just going to use something different, H for hours. But you could use X if you wanted. And then doesn't he want that money to add up to $160? Okay, so what do I need to do first? And so now I have $6 an hour equals what? Okay, now to solve for the hours, I divide by 6, and so hours equals 19, right? Now let's make sure that makes sense with the calculator. Okay, if you work 19 hours, and how much are you making each hour? So times 6. That's how much you would make from those 19 hours, but didn't you already have $46 saved? So is that enough to go to prom now? Yeah. Yes. Okay. Matt wants to call his mother long distance. The rate is 80 cents for the first 3 minutes and 20 cents for each additional minute. How long can he talk if he has $3? So what is our total? Right, so it's going to equal 3. And then what all is in the equation? Okay, so 80 cents covers 3 minutes. Okay, once you pay 80 cents, you get 3 minutes of talking time. But then if you want to talk more than that, you pay 20 cents per minute, right? So now to solve for how long he can talk, what do you do first? Subtract 0.80. It's like subtracting 80 cents and subtract it from $3. And that leaves you how much money left to talk more? $2.20. Hold on one second. So what do I do next to solve for M? Divide by 0.20 on both sides. So M equals 11. Does that mean that Matt can talk to his mom for 11 minutes? No, because think about it. If you go back and do the math, 11 minutes. How much was each minute? 20 cents. Well, that would only cost you $2.20. And he had how much money? $3. So he still has how much? And how much would that 80 cents have got him? 3 more minutes for a total of 14 minutes. Okay, try this one. It's pretty much the same kind of problem, so just try it. Right, 0.60. Don't forget that decimal point, otherwise it's like $60. Plus 0.15 M equals $1.35. So what do we do first? Right. And then get 0.15 M equals, and now we, and so M equals 5. Okay, but isn't that just the 5 minutes for 15 cents each minute? So how many total minutes can she talk? 10 minutes. Okay, now go ahead and turn to the next page. Okay, the next page, in my opinion, they're super easy. So instead of me like working out one and just giving it to you, I would like you to look at this first example and try to teach yourself. Okay, so look up here at this first example. Now, one thing I do want to show you is they wrote -7 kind of weird. It makes it look like an exponent. We normally write it like this, -7, -7. They just wrote it in a weird place. Okay, so don't get that confused. So read through this, see what they did, and then try the rest of these on this page. I'll give you a few minutes. Pretty easy? Okay, I'm thinking of a number. Well, right now, nobody knows that number, so I have to put X. It's unknown. But what I do know is that I'm going to multiply that number by 4, and I'm going to add 13 to it, and when I do, I get 37. So now to actually figure out what my number I was thinking of, I just have to solve for X. What's the first step? Subtract 13, and that gives me 4X equals 24, and then I would do what to solve for X? And if you divide that by 4, you get a 6. So, and go back and make sure it makes sense. If 6 is the number you're thinking of, and you multiply it by 4, you get 24. And if you add 13, doesn't that bring you up to 37? Well, I mean, you need to know how to write it, though. Okay, I'm thinking of a number. Okay, so here's my number. I don't know what it is yet. I'll multiply it by 8. Sit down, Jamie. And then I add 17. That's the name I chose today.
Oh, no.
Equals 33. I like Jamie. Okay, now what do I do? Subtract 17. And I get 8X equals, no, 16. And then I divide by 8 on both sides, and I get X equals 2. Okay, I'm thinking of a number. I multiply by 5, I take away 7, and that gives me 53. So once I do all the math, add 7, that'll give me 60, divide by 5, and that'll give me 12. So the number I was thinking of is 12. Alright, I'm thinking of a number. I multiply that number by 8. I subtract 13, and that gives me 43. So what do I do first to solve for my missing number? Okay, when I add 13 to both sides, that gives me 56, and then when I divide by 8, that gives me 7. Okay, this was the one that gave people some trouble. I'm thinking of a number, okay, so X. Multiply it by 5, subtract 24, and then you will get, which means equals, the number I'm thinking of. Well, we don't know the number you're thinking of, so you have to use X again. Didn't we use X over here for the number I was thinking of? So you have to put it over here because it says the number I'm thinking of again. Now, what's the first step for this one? Well, think about it. If I add 24, isn't that just going to throw it to this side? Minus 5X, and then the X's will both be on the same side. So now I have negative 24 equals 1X minus 5X is Negative 4x. Like if you have $1, but you would try to spend 5, wouldn't that put you $4 in debt? Okay, now you divide by negative 4. And so what is negative 24 over negative 4? Positive 6. Okay, hey Randy, I'm thinking of a number. If you multiply it by 5 and then you add 3, you will get 48. I got it, kid. You're thinking of the number 6. Okay, when Randy set up the equation, did he set up the equation correctly? Yes, here's the number, multiply by 5, add 3, you get 48. But his next step,
8 times 6.
right, here's where he went wrong. He combined those to 8x. Does that 3 have an x? So you can't combine them. He had the right equation, but instead of combining them to make 8x, what should have been done? Right, they're unlike terms, so the 3 has to go over with the other constant, and now you have 5x equals, and then when you divide by 5, you get x equals 9. Okay, once you've copied that, go ahead and go to the next page. Pay attention. A 48 centimeter piece of wire is to be cut into 2 parts. One piece must be 10 centimeters longer than the other. How long should the pieces be? Okay, since you're cutting this wire into 2 parts, that's why they had a need for 2 different X's to represent part 1 and part 2. Now, they told us one of those pieces was 10 centimeters longer than the other. So see how they added 10 to one of the pieces but not the other? And then it equaled up to 48, the total length of the wire. From there, they just combined like terms. X and X became 2X. Then they subtracted the 10 on both sides, and that's how they got the 38. And then they divided by 2 on both sides, and that's how they got 19. 19, though, just represented the x by itself. So to get the other value, wouldn't you have to add 10 to that? And those are your 2 lengths of your wire. And do those 2 lengths really add up to the total 48 centimeters? Yes. Okay, so let's try this next one. A 16-foot board is to be cut into 3 pieces. Okay, if it's to be cut into 3 pieces, how many X's do we need?
3.
So 1, 2, 3. Now, don't we know that it totals up to 16 feet? But what else did they tell us about the pieces? Right, okay, so let's just consider this as our 3rd piece right here. We're not going to do anything to it. But to our 1st piece and our 2nd piece, aren't they 4 feet shorter? How do you represent that? Minus 4 and minus 4, right? Now, don't the 3 pieces together total up to 16 feet? So does everybody understand how I set it up? This is piece 1, this is piece 2, and this is piece 3. But they told us piece 1 and 2 were 4 feet shorter than piece 3. So you have to write minus 4 on both of those. Now what do I do? Well, now combine like terms. So x plus x plus x is 3x. And then I have a negative 4 plus a negative 4, which is a negative 8, and then equals 16. Now to solve for x, what do I do? Add 8. So that gives me 3x equals 24. And now I divide by 3, so x equals 8. Now, x, just a regular x, that's the 3rd piece, which is the longest, right? So if the longest one is 8, what are the other 2? 4 and 4. And do those 3 lengths add up to 16 total feet? Yeah. Yes. Okay, we're going to jump around a little. I want you to go up here and try this one by yourself, the $500 one. How can $500 be divided between 2 people so that one person gets 50 more than the other? What does my equation look like? Right. Did anybody write x plus 50? That's the same thing, because didn't everybody in their 2nd step get 2x plus 50? So it doesn't really matter where you put the plus 50. They didn't tell you which person gets 50 more. They just said one person gets 50 more. So you could have added it to that x or that x. It doesn't matter. Now to solve for x, what do? right? And so that gives me 2x equals 450. And now what do I do? Divide by 2, so x equals 225. Now, that's just regular x. That's not the person who got x plus 50, right? How much did he get? 275. And did those amounts really add up to 500? Yes. Alright, the band leader wants to line up the 92 band members in 4 rows so that each row has 2 more members than the row before. How many members should be in the shortest row? Okay, well, how many X's do we need? 4. 1 for each row. And those 4 rows are going to total up to what? 92. Now, what do we know about those 4 rows? Each one is 2 more than the previous, right? So, here's row 1. Here's row 1. Here's row 2. Here's row 3. Here's row 4. How do you represent 2 more than the previous row? Plus 2. So, there's your row 2. Plus 4, right? Because think about it. This plus 2 would make this row 2 more than that one. But to be 2 more than this one, don't you have to add 4? And so for this one, you would have to add 6. Now when you add up all 4 rows, it equals 92, and it equals 4x plus 12 equals 92. And now what do you do? Okay, and you'll get 4x equals 80. Because you had to subtract 12 on both sides, and then divide by 4, so x equals... Okay, regular x represents which row? The first one, which is the shortest. And they ask how many members should be in the shortest row? 20. And if you wanted to, you could go ahead and write out the rest of the rows just to confirm that it makes sense. Do those 4 values really add up to 92? Yes. But this is the answer because they just wanted to know the shortest row. Okay, Raul has to finish a 473-page book in a week. He decides to read the same number of pages each weekday and 30 extra pages on Saturday and Sunday. How many pages will he have to read on Wednesday? Okay, well, I'm going to write x plus x plus x plus x plus x. That represents Monday, Tuesday, Wednesday, Thursday, Friday, each weekday, because he's reading the same amount, so they can all just be a regular x. But then come Saturday, isn't he going to read what he read Friday plus 30? And then on Sunday, isn't he going to read the same amount he was reading all week, but plus 30? So look, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Saturday and Sunday have 30 pages extra each day. So now what does that combine to be? 7x plus 60 for the 7 days a week of reading plus 60 extra pages on the weekend. Equals up to what? 473. Now to solve for x, what do we do? Subtract the 60 on both sides, and that gives us 7x equals 413. And then what do we do on both sides? So x equals... What's 413 over 59? Isn't the regular x's the weekdays? So how much would you have had to read on the weekend? 89 each day. But they want to know how many you have to read on Wednesday, so the answer is 59. Okay, a store owner sells 2 pair of running shoes for each pair of high tops. So we have running shoes and we have high tops. Now, don't we know for every 1 pair of high tops he sells 2 pair of running shoes? And then he plans to order 144 pairs. So does everybody understand how I set up the equation? Now what do I do? Right? And now what do I do? So x equals 48. Okay, does regular x represent high tops or running shoes? No. 2x represents running shoes, 1x represents high tops. And that's what they wanted to know, so that's your answer. Had they been asking for running shoes, what would your answer have been? Which would be 2 times 48, so 96 pairs of running shoes. Okay, there's no homework tonight. You can switch out.